You don't really need to use the restrictions to determine extraneous solutions, because the easiest way is really to just plug it in. However, we should know how to state our restrictions. Okay, so the domain restriction on this is, if we look at the inside restriction, x must be greater than or equal to -2. Okay, so if it's -2, we end up with 0, and that's okay. Anything smaller than that is going to give us negative. So the outside restriction is going to be x must be greater than or equal to +5. Okay, because if we have anything smaller than 5, we're going to get a negative on the outside. Okay, so the square root ends up equaling a negative, which is not possible. Okay, so we can actually put these together. Putting these together, it just ends up being x is greater than or equal to +5. Okay, it has to be both. So once we've done that, we can go ahead and solve this equation. Okay, we're going to square both sides, and remember, this is where we introduce the possibility of extraneous solution, because we're going from the square root, which is half a parabola, we're squaring it, which means that the square root could have been the positive version or the negative version, and we're going to end up with the same thing. Okay, we're going to end up with x plus 2, whether it was positive or negative. Okay, so we're using both halves of the parabola instead of just the top half. So we end up with x squared minus 10x plus 25. Don't forget to FOIL this out. It's a quadratic, so we'll make that equal to 0. So we end up minus 11x plus 23. Okay, so this is, looks like that's not factorable. 23 is a prime number. So I'm going to plug this into the quadratic formula. So x is equal to negative of -11 plus minus square root 121 minus 4 times a times c. Okay, and this is all over 2a. Okay, simplifying this, 121 minus, this looks like it's going to be 92. 4 times 23 is 92. So 121 minus 92 is going to give us 29. So square root 29 all over 2. Okay. So square root 29 is approximately 5. So we're going to end up with, it's a little bit less than 5. Or sorry, a little bit greater than 5. So we're going to end up with, let's just say 5.5. And so we're going to end up with 11 minus 5.5. So 5.5, half of that's going to be about 2.75. Now the 2.75, and if you want, you can work out the decimal value here. Based on the restriction, we should be able to determine that that is an extraneous solution. Okay, so let me just work this out. 11 minus square root 29 divided by 2, I'm getting 2.81. It's approximately equal to 2.81. Okay, so based on our restriction, based on our domain, okay, based on the domain, we're going to say that that is an extraneous solution. Okay, so that is extraneous. Okay. Work out the other solution. Okay, so it's going to be 11 plus square root 29, all divided by 2. And I get 8.19 approximately. So it's about 8.19. Okay, based on our domain restriction, it looks like this is a good answer. Okay, so when we plug it in, you can always check it using the decimal value. So square root of about 10.2 is equal to about 3.19, which is going to be correct. So this is our solution here. Okay, and if you're unsure, we could always check it. If you have a calculator, you can just plug it in, you do the approximations, and you can get a good idea. However, if you're confident with the domain restrictions, we can just go with the domain restrictions. But if you're ever in doubt, you can always plug it in. Work out the number and plug it in. Okay. And maybe we should just quickly look at what that graph would have looked like, just so that we have a graphing perspective as well. So that's going to be my square root of x plus 2. Okay, and this is going to be my y equals x minus 5. Okay, so there's my 8.19 solution right there. That's the one that we wanted. The extraneous one was the one that showed up, which was 2.81, and that's going to be this one here. Okay, it's going to be that one that showed up there. That's our extraneous solution. Okay, so let's take a look at this one here. Again, we should state our domains. Okay, so our domain restrictions. We need to make sure that x is greater than or equal to negative 12 over 8. So let's simplify that to 3 over 2. And x must be greater than or equal to negative 3. So those two together is going to be x is greater than or equal to positive 3, negative 3 over 2. Okay, so it's got to be bigger than negative 1.5. Okay, so there's my domain restriction. Go ahead and solve this algebraically. So I'm going to square both sides. Again, whenever I square both sides, I'm introducing the positive and negative versions of that square root, so we're going to end up with the possibility of an extraneous solution. And just algebraically make sure that you're expanding using FOIL, or the distributive property. So I end up with x squared minus 2x minus 3. I think this is factorable, so we end up with x minus 3, x plus 1. So we get solutions x equals positive 3, x equals negative 1. Okay, well, both of these solutions fit my restriction. Okay, so both of these should be okay. I'm not super confident with my domain restriction, so I'm just going to go ahead and check this. So I'm going to check the solutions, or test the solutions. We should just say test, because this is actually a test, isn't it? We're going to test our solutions. So testing x equals 3, we end up with square root 24 plus 12 is equal to 3 plus 3. So square root 36 equals 6. Yeah, that's okay. So I'll test x equals negative 1. So I end up with negative 8 plus 12 is equal to negative 1 plus 3. So I get square root of 4 is equal to positive 2. Yeah, that's good as well. So yeah, that based on the restrictions, everything's good. Based on our test, everything is good as well. Okay, and again, if we should have an idea what this should look like visually. This is going to be a parabola that looks like that. We have our solutions that go through x plus 3, y equals x plus 3. There are my two solutions. There's a solution at 3, and there's a solution at negative 1. Okay, so that's what the graph would have looked like. That graph would have, the linear equation, the x plus 3 line, cuts through that curve in two spots like that, giving us two solutions.